Example 4 wants us to find all values of x on the graph of f of x at which the tangent line is horizontal, where our function f of x is equal to 1/3 x cubed minus 3x squared plus 5x plus 10. The first thing that we want to do is we want to take the derivative. So we do that, we get 1/3 times 3x squared minus 3 times 2x plus 5, and there's no more terms because the derivative of 10 is 0. So let's clean that up. So we get f prime of x is equal to 3 times 1/3 is 1, so that's going to be x squared minus 6x plus 5. And remember that this gives us a function that helps us with a lot of things, like finding the instantaneous rate of change, but it also helps us find the slope of the tangent line at various locations. And when the tangent line is horizontal, its slope is going to be 0. So what we want to do is we want to set our derivative function equal to 0 and solve for the x values that make it 0. Now, if you take a look at this function that we have here, this is a quadratic function, and there are a couple of ways that you can solve this equation. Now, recalling from algebra, one of those ways is by using the quadratic formula. So that is one thing that you can do. I am going to, I think, do the quicker method of these two, and that is by factoring. So I have 0 equals x squared minus 6x plus 5, and I'm going to factor this thing. We know that two numbers that add to -6 and multiply to 5 are -5 and -1. So that's going to mean that our factors are x minus 5 and x minus 1 are equal to 0. And then from there, we can use the zero product principle or the zero product rule that tells us that we can set both of the factors equal to 0 and solve. So we get x equals 5, and then if I add 1 on both sides here, we get x equals 1. And so that means that f of x has horizontal tangent lines when x equals 1 or x equals 5. Example 5 wants to find all values of x on the graph of f of x at which the tangent line's slope is 7, where f of x is the same function that we saw in example 4. So since we already dealt with this function, we found that the derivative in the previous example was x squared minus 6x plus 5. And instead of setting it equal to 0 this time around, we want to find the locations, the values of x that make the slope of the tangent line 7. So we are going to set it equal to 7 and solve for x. I'm going to subtract 7 on both sides of the equation, and that will give us x squared minus 6x minus 2 is equal to 0. Now, that is not nicely factorable, so I'm going to use the other method that I referenced, which is the quadratic formula. So the quadratic formula is x equals negative b plus or minus b squared minus 4ac all over 2a. So if I fill in those values, we get x is equal to 6 plus or minus negative 6 squared, which is 36, minus 4 times 1 times negative 2, all over 2 times 1. So let's do some simplification there. We get x is equal to 6 plus or minus the square root of 36 plus 8 over 2, which turns into 6 plus or minus the square root of 44 over 2. And then we can rewrite that as 6 plus or minus the square root of 4 times 11 over 2. That works out nicely because then we can separate that into two different square roots. Okay, so when we get to this point, both the 6 here and the 2 here are divisible by 2, and so we can divide, and that will simplify to 3 plus or minus the square root of 11. So here is our final answer. When we plug in 3 plus the square root of 11 or 3 minus the square root of 11 into this function, the slope of the tangent line at these two x values will be 7. So that's what these x values represent. For any positive integer n, the nth derivative of a function is obtained by differentiating n times. The nth derivative is written like this, where it kind of looks like f to the power of n of x, but it's not a power or an exponent, it's just a superscript. So, for example, if we wanted to find the 8th derivative of something, it would look like this, f superscript 8 of x, like that. However, a caveat to this notation is that the first three look a little bit different. So the first derivative is f prime of x, the second derivative is f double prime of x, and then the third derivative is f triple prime of x. And then generally after that, you start just putting the number. So then it would be f like that. So that would be the fourth and the fifth derivative. So example 6 wants us to find the fourth derivative of f of x equals 5x to the 10th power minus 6x to the 5th power minus 27x plus 4. So the first derivative is going to be 50x to the 9th power minus 30x to the 4th power minus 27. Then we want to find the second derivative, and that's going to be 50 times 9 is 450. 30 times 4 is 120. And then the derivative of 27 is just 0. So then our third derivative is going to be 3600 x to the 7th power minus 360x squared. And finally, our fourth derivative will be 25,200 x to the 6th power minus 720x. And that is our fourth derivative. The marginal revenue R prime of x is used to estimate the change in revenue caused by the sale of one additional unit. Example 7 says, Mr. Kwan decides to sell those things that shock your abs that supposedly gives you a six-pack. The revenue for selling this product is given by the function r of x is equal to 1500x minus 0.02x squared, with the x values ranging between 0 and 1,000, where x is the number of units sold and r of x is in dollars. Part A says find the marginal revenue at x equals 500. So the first thing that we want to do is we want to find the marginal revenue function, or r prime of x, and that's going to be 1500 minus 0.04x. And now we want to find r prime of 500. If we do that, we get 1500 minus 0.04 times 500, which is equal to 1500 minus 20, which equals $1,480. So we can interpret this to mean that the approximate revenue from the sale of the 501st unit will be $1,480. Part B says find the change in revenue caused by the increase in sales from 500 to 501 units. So what we want to do is we want to find R of 501 and also find R of 500 and subtract those. So R of 501 will equal 1,500 times 501 minus 0.02 times 501 squared. And if you simplify that, you should get 746,479.98. And if we calculate R of 500, if you simplify that, you would get $745,000. And then if you subtract those, R of 501 minus R of 500, the difference ends up being $1,479.98. And notice that the marginal revenue at x equals 500 is a good estimate of the revenue from the 501st unit because in the previous example, we estimated the number was 1480. So the actual revenue gained was only off by 2 cents.